In the previous video, we set the state space model. Alright, in this video, we'll talk about a more common way of setting up the state space model. And therefore, in this video, this is a more a common way, often we are using it every time. Alright, and what is it every time is because we are going to write in terms of x. Alright, we're going to write in terms of x. What do I mean by writing in terms of x? In the previous video, we actually say that xt is in terms of theta dot and theta, correct? But in this case, I want to set up in terms of x1, x2, and x3. Okay, so what can I do about it? Alright, so so I'll just repeat again, this method right now is the one that we will be using throughout everything. Alright, so take note. Therefore, if you still remember the first step from our previous video, okay, we identify the highest order of the variables. Theta is the variable right now, right? So the highest order is second order over here. And therefore, I'm going to write the equation in terms of this second order. And therefore, I'm going to bring this onto the side. Alright, so I'm bringing them onto the side with a minus sign over here. Okay? Yep. Now we identify what are the variables x, theta dot, and theta. Now a special way to write this is that x1 is equals to theta. Alright, so I sub theta in terms of x1. Alright, and if I were to x dot 1, I will say that x dot 1 is equals to x2, alright, which is equals to theta dot. Alright, x1 dot is just simply theta dot, alright, is what I've shown you over here. Okay, now I can rewrite x1 dot as x2. Now I differentiate x2 now. x2, as you know, is theta dot. If you have to differentiate one time, you have theta double dot. Okay, to reach this, alright, this is just x2 dot. And if you still remember, we are talking about the variables over here and over this side, alright, the right hand side of this equation. And therefore, you see that this theta and theta dot represented by x1 and x2. Alright, so these are the variables, and therefore we can represent x2, x1 over here as xt, and this is 2 times 1. And therefore, if this is 2 times 1, as I say in the previous video, only applies for this first equation. If the xt is 2 times 1, then the result x dot t is also 2 times 1. Alright, so this is x dot t. Alright, so xt differentiate one time will become x dot t. That's the meaning. And therefore, if I differentiate x2 one time, I'll have s2 dot. So if I differentiate x1, I'll have x1 dot. Alright, and therefore this is simply the same as theta dot double dot, and this is in terms of theta dot. Okay, and this is a method of actually writing things in a more neater way. Okay, and then since we know that this is 2 times 1, the matrix itself over here should be 2 times 2. Okay, and then obviously I also explained that why can't this be 1 times 2. Okay, it cannot be 1 times 2 is because x1 dot is equals to x2, so I can represent them in terms of this thing. As you can see, this is a more clearer view, right? So x1 dot can be represented as x2 over here, and this is the reason I use 2 by 2. Alright, so you need to know when do you use the stuffs, and then plus, now if you still remember, this is also must be 2 times 1, and then I'll have te over here. Right, in other words, this is actually ut, which is this one. Alright, and this is b is for over here, and this is a. Alright, so I'm just simply rewriting the whole equation only, axt. So this is axt. Okay, I think this is pretty much clear. So in the previous video, we actually talked about this equation stating that the output itself, the output itself depends on the lowest degree, which is in other words x1. x1 is, if you remember, we started off with equals to theta. So the outcome is always the lowest degree over here. Alright? And therefore I can simply write theta as 1 times 1. Alright, instead of writing theta, now I write in terms of x1. Alright? So this is exactly the same as what we have written in the previous video. Okay? And then this is a 1 times 2 matrix. And then similarly we just write in the x2 and x1. Alright, because in the equation over here, as you can see, this is in terms of x also. Alright, and therefore I can just simply paste this one over here. And likewise, the ut is also the same. But now, instead of this matrix be 2 times 1, because we know that this one is 1 times 1, alright, we have to ensure that this is also 1 times 1. Okay, the outcome is 1 times 1. This is based on the matrix addition rule, if you still remember. Alright, if you want to add up one matrix with another matrix, you have to ensure that they are both in the same order, 1 times 1, 1 times 1. If it's 2 times 2, then this must be 2 times 2 also. Okay, this is just the rule itself. And therefore, if I were to do that, and therefore this is 1 times 2. Okay, and then the rest of the coefficient, I believe you already know how to sub in. Alright, because in terms of, so therefore, alright, this theta dot is in fact now x1. x1 dot is simply x2, so I'll just write as s2, and then theta I can simply write as x1. Okay, so the coefficient of x2 is minus c over I, and therefore I can just sub in over here. Similarly, the coefficient for x1 is minus mgl over 2i. Alright, and then 1 over I. Alright, this is the coefficient. Perhaps 1 divided by I is times t. Okay, and therefore this whole portion over here, including this lah, okay, describe this differential equation. Okay, and then x1 dot is equals to x2, correct? And therefore I can just simply write as 1, 0, 0, because x1 dot is simply x2 and that's it, right? Nothing much. And this is a more defined or more clearer way, right, compared to the previous video. But I just want to show you the concept of why this is something much useful than the previous method of doing. Okay, although I know that it's wasteful of time, but at least this is the reason behind why. Alright, and we know that x1 is simply x1 itself. Alright, x1 is simply x1 itself. But because we want to know that what exactly is x1, x1 is equals to theta. Right, if you still remember, x1 is equals to theta. This is the information, and therefore instead of x2 and x1 over here, I'll just keep it as just keep it as theta dot and theta. Alright, theta dot and theta is simply x2 and x1. Okay, so theta is x1, theta dot is simply x2 or theta dot. So I'm just simply writing this in terms of this, okay, because I just want to define it more properly. And therefore x1, right, x1 is equals to theta, so 1 times theta is equals to x1. Alright, and then there is no the top equilibrium moment, therefore it's 0, because the equation itself is simply x1 is equals to theta, and that's all. Alright, and therefore this describes the state. Alright, for x1 the state is equals to theta. Alright, it is just simply theta itself. And the state for this scenario over here, the first row, alright, the first row over here is simply describing the state of this differential equation. Alright, so all in all, this is just describing the state. Alright, so in the next video we'll talk about describing the natural frequency and things like that, which is the next video. And I shall see you there.